Welcome to the course on Internet Crimes and Cybersecurity. Today's topic we are going to discuss is basics of cyber control systems. It is going to be taken care by me, by B. Muhammad Irfan, Technical Coordinator Cybersecurity, Nalsar University of Law, Hyderabad. In this topic, we will be discussing about control systems, cyber physical systems, industrial control systems, cyber control systems, SCADA workflow. SCADA works as a cyber control system, cyber threats to control systems, securing cyber control systems, cyber control system standards and regulations, and conclusion. So what is a control system? Control system is a set of devices managing, commanding, directing, regulating behavior of a system. So what is the example for this? Okay, the FASTag toll plaza is one of the example for control systems, where standalone wise, normally when a vehicle enters the toll plaza or a toll gate, there is a teller. The teller will note down the car number. He will note down the time, date of arrival, date of departure, if there is a delay, and he will be giving you a receipt of you going through the toll plaza. So this is a normal procedure. How is this been changed into or converted or upgraded through a control system? So when control system comes, we are going to have efficiency, accuracy, pace. We can further improvise into upgradations. We will have more things to be followed. So instead of a teller doing it, okay, a system works on it. A system is made up of group of components. These devices work in a tandem and they perform the operation. What is the operation they perform? Teller issues a receipt. Whereas this control system, as and when the vehicle goes into the toll plaza, first stops the vehicle with the help of boom barrier. Then on top of boom barrier, we have number plate reader. And beside it, a camera, which is a number plate reader. Beside it, we have a RFID tag reader or RFID recorder. Then we have other things related with updating of the number. There will be a display panel which says that payment received, number registered, welcome, something like that. Okay, hold or something like that. So when the vehicle goes in, instead of you interacting with the teller, you will be looking into the CCTV cameras. You will be looking into the number plate reading cameras. You will be looking into some kind of RFID scanners. Once it has been successfully done, they perform their operations. The boom barrier gate will be opened. So there are many sensors. What are the sensors? We have sensors which are recording the RFID tag which is connected to your car or vehicle. Then we are going to have controllers. The controllers which, after recording the number plate and also recording the RFID tag, the boom barrier opens. The boom barrier opens with the help of controller and accumulators, and these things are connected with the help of a communication device. So this example of a toll plaza where your RFID reader is registered, recorded, reported, and also updated is called a control system. Now we will go to the next level. Now we have spoken about one toll plaza. When you go into cyber physical systems, the same toll plazas, there will be 5 toll plazas, 4 toll gates in one line. Okay, 5 or 6. 3 will be for inwards and 3 will be for outwards. Apart from that, we will have hundreds of toll plazas in India. Okay, and these all toll plazas are being connected to a cloud environment. There is application by which it has been connected to a cloud environment. In the cloud environment, all the transactions which are happening in one toll gate are going to be recorded, reported, registered, and it has been disseminated to the respective stakeholders. So what is cyber physical systems? It is integration of physical process, that is whatever is happening on the toll gate, with computing and network. Okay, so if there is a command and control for a National Highway Authority of India, okay, the National Highway Authority of India will sit in one place. He will have real-time monitoring of the number of vehicles which are being going through different toll plazas or toll gates in India, and they will see how they are being, how the process is working, how the money is collected. Okay, if there is any delay, what is the delay reason, and if delay is there, they can easily communicate with the maintenance team to understand what's the road status, and they can also understand the traffic. If there is a highly accumulated traffic, they can apply different operations research, statistical data science driven algorithms, and they can moderate the vehicle flow in the traffic much before the traffic gets congested. So this is called cyber physical systems. Okay, then you can see the image. In the image, you can see the objects, which are sensors, which are RFID readers, which has communication devices, which are being connected to the network, and then it is being connected to the cyberspace. And using applications, the people who are the stakeholders will be accessing the data from the cyberspace. Understand, even a car vehicle owner, okay, can also trace how many chalanas he has paid, how many toll gates he is going to pay in the due course of his traveling from one destination to another destination. He can even see the traffic for the forthcoming toll plaza, and he can even predict how much money he has to pay to reach to his destination. So this is all happening because of cyber physical systems. Then we are going to see industrial control systems. In industrial control systems, the same application is going to be seen in industrialization manner. Like means vehicle manufacturing facility. We are talking about poultry and animal husbandry, interfaces for agri-tech. We are talking about we can say any industrial pharmaceutical companies where we need to reduce human interaction. We want to make sure that efficiency and accuracy is maintained with persistency. Then we will be having industrial control systems where industries are being handled by control systems. Okay, industrial process is being handled by control system. However, this is going to be done with the help of SCADA. SCADA is an application which is a framework by itself, which will help you to communicate or manage or moderate different operations of a industry differently located in different locations. Okay, and moderating and controlling the entire workflow is going to be done by SCADA. You can see this is being done by distributed control systems. It can be done by programmable logic controllers. So this is called industrial control systems. Now we have understood control systems. We have understood cyber physical systems. We have understood industrial control systems. Then we are understanding cyber control systems. Cyber physical systems. Cyber control systems. So what are cyber control systems? Cyber control systems are a combination of hardware, software, sensors, controllers, communication channels, human machine interfaces that enable automated or semi-automated control of physical process. Okay, now what is this happening? In the cyber physical systems, physical activities are being controlled by in the cyber world. In cyber control system, the control systems are being managed by the cyber world. Okay, managed through cyber world. So this is also done with the help of SCADA. It is also done by the help of industrial control systems, distributed control systems, programmable logic controllers, or remote terminal units. Okay, how are we going to make sure that, see, there is a physical activity. The physical activity is managed by control systems. So in the next phase, we call it as cyber control systems. Then we are going to have industrial control systems. Then we have seen cyber control systems. In the cyber control systems, it is not about physical systems. We are talking about control systems, how it is going to be in the cyber world. Okay, now example of toll plaza or FASTag. Okay, the devices which are being connected, okay, which are being controlled by control system is cyber physical system. Okay, now in cyber control system, the controllers will be managed. The controllers which are part of the control system, which are part of the cyber control systems, will be managed. So that we are going to create security to the control systems. Okay, that is the cyber part of these control systems, not the physical process. Okay, not the physical process, but the cyber control systems. So this, how are we going to protect? We are going to create hardening, physical security, perimeter security, segmentation, escalation, and privilege defining. Okay, protocols, privileges, and creating procedural awareness. We will be making sure that our control systems are having a security around it, and these control systems which are a part of cyber control systems are secured. Then what is SCADA? SCADA is a powerful system used across industries to remotely monitor control missions. Okay, so using SCADA framework, you sitting in your home or in your workspace remotely, okay, can monitor, manage a industrial process happening in a industrial corridor. Okay, so you can you can understand the pipeline. You can halt some device manufacturings for a brief period of time. You can escalate some device processings. That means sitting remotely, you can see example of SCADA system is drone. Okay, remotely controlled drones, unmanned drones, people sitting in somewhere in Washington or some air base in Middle East, okay, are using drones like UAE drones like Reaper somewhere in somewhere in Iraq, okay, traveling at 35,000 feet in the air, okay, and scanning, reconnaissance, ISI activities or terrorist activities, and sending live data to the control system where they can take decision of neutralizing any of the terrorist activities. So this is example of SCADA. Okay. So SCADA is not only used for it's defense and security. It can be used for manufacturing, energy, oil and research, water treatment and transportation. Okay. So how SCADA works as a cyber control system? It enables remote monitoring and control, very important. It captures huge amount of data. It does bi-directional communication. It can send data, it can receive data. Integration into IoT devices. That means if you have a SCADA in remote in your place, remotely located from the physical activity, you can connect it to your mobile device. You can connect it to your watch your wearable interfaces. Using this, you can even monitor real time. You can mitigate, navigate, control, and you can transfer a lot of communication. So SCADA is not only a remote controlling system of a business process, of a event management process, but also it can be integratable into IoTs. Okay, so we have understood control system, we have understood cyber physical systems, we have understood industrial control systems, we have understood cyber control systems. Okay, now we are going to understand what are the threats for the control systems. Now, one of the example of control system is uranium enrichment plant in Iran. Okay, what happened is that in the year 2007 to 2014, if I am right, in 2024, from 2009 to 2024, okay, there was a attack on one of the nuclear refinement center or facility in Natanz in Iran. Okay, how does this happen? Actually, all their all their physical activities or refining facilities are disconnected from virtual world. Okay, they are working in a given location. In the given location, there is a industrial process. It is been controlled by some control system, but it is not cyber control system, or it is not cyber physical system. So they made it a standalone system. So this Mossad and CIA have decided that they will damage and destroy centrifugals which are meant for refining the uranium in the Natanz uranium refinement facility. So what they did was that they somehow managed to put the worm or virus in a pen drive, and they made the facility, that pen drive is connected to one of the systems, okay, of the facility. From there, they damaged the entire cyber control system. They took over the entire cyber control system. They increased the speed of the centrifugal rotation in 6 to 7 years of time, from 2009 to 2024. That means almost some 13 years of time. They have made sure that the entire centrifugal rotation of refinement of the uranium has been distorted, disgrunted, and everything was damaged. Okay, this is the example of how cyber threats can be on control system. So what are the control systems we have? We have toll plaza as one of the control system. We have income tax department, processing is as one of the control system. We have, we can say, airport authority of say, it is also, they are being connected to each other. That is also a control system. So wherever there is a control system in place to manage physical activity of a business, okay, whether it is industrialization, whether it is a production management, whether it is a energy and other processes, whether it is the education system, there is a possibility that a cyber attack can happen, a cyber threat can be conceptualized, and its control system can be taken down. So what are the different types of cyber threats? One, malware, example is trustnet, which we have discussed. Then denial of service attack. Then man in the middle, unauthorized command injection, spoofing of sensor. The sensor, let's suppose we are talking about toll gate. Okay, imagine that there is a spoofing of the sensor happen. That means the RFID tag reader, okay, is been hacked, and instead of reading the RFID tag in 7 seconds, it is taking nearly 25 seconds to read it, register it, and report it to the database. Imagine that this happens in a festival season like Dasara, Sankranti, anytime. Okay, and instead of entire transactions being completed in 7 seconds, it takes nearly 25 seconds. So you can see huge traffic congestion. There may be breakage of entire traffic also, inter city traffic, because of toll plazas are being taking more time than it should be. So this is an example of cyber attacks on control systems, and sometimes it can be happening on supply chain attacks also, supply chain management systems also. So how we are going to secure a control system? We have a control system. First, we have to make sure that there is a perimeter security. Around perimeter security, we will have a network security. Around network security, we have a endpoint security. Then we have to create application security and data security. Okay, so perimeter security is going to be a monitoring and response mechanism. Okay, and it will be helping you for proactively policy management. So perimeter security can be done with the help of network segmentation. Okay, network security can be done by firewalls and intrusion detection systems. Endpoint security can be done by endpoint hardening. Okay, application security can be done by vulnerability patching. Okay, data security can be done by access control. Okay, then we are going to see cyber control system standards and regulations. So we will not be dwelling more into this, but we will be saying that most of the cyber control systems which are in place for industrialization, for revolution of industrialization, can be managed or may be protected. The control systems can be protected. The cyber control systems can be protected by the help of framework like NIST framework of ICS, IEC 62443 Industrial Security Standards, ISO standard. Okay, DHC, ICS is certain guidelines and certain advisories. So if you want to make sure that the cyber control system is secured from any kind of cyber attacks, okay, you have to make sure that that cyber control system fully qualifies to the regulations and standards of these 5 frameworks. One is NIST framework, IEC 62443 Industrial Security Standard Framework, ISO 27001 Information Security Framework, DSC, ICS, certain guidelines and certain regulations. Okay, this is what we have to do. What are the future trends for cyber control systems? We are seeing, take the example of toll plaza. Okay, what is the next level of toll plaza we are going to see? Next level of, we can say, toll plaza evolution we can see. Now, Nitin Gadkari is saying that we are not going to, monitor your passing from one place to another place by toll gate. We are going to calculate your wheel rotation, how many kilometers you are going to travel. Okay, and it is going to be registered by different kinds of sensors, and based on that your toll fees can be connected. So they are using AI driven predictive control systems, and they are going to charge you based on the amount of number of kilometers you have traveled by putting a lot of AI driven sensors in the along the road. Okay, so this is an example of future trend. Digital twins is another future trend. Automation of industrial systems from physical control systems is another. Edge computing is another trend we are going to see. Quantum safe security models is also another trend we are going to see. So these are various trends we are going to see in the part of cyber control systems implementation. So what is the conclusion? In the conclusion, we have understood that consumer-wise protection of cyber security, application of cyber security for protecting the individuality, identity, data of a person is very important. But okay, understanding the control systems, understanding the industrial control systems, cyber physical systems, and understanding how cyber control systems are going to work in different domains is very important. Because if not, from your mobile, the same data can be hacked or can be breached from anywhere you are being connected to. Okay, always remember that cyber attack happens for a person, for a on a society or a group of people. So always remember these cyber attacks. If Irfan has to be the breach and his private or physical secret information say has to be snatched or hacked, what will be done? It is not necessary that they had hacked into my mobile. They can go into a college website or a university website or a organization website where I am being associated. From there also they can hack. So there we have to have a cyber control systems, and we have to have securing ICS and CPS essential for secure critical nature. Understanding architectures, threats, and security frameworks is very important. Fundamental future demands like intelligent, resilient, and up to control systems should also be in place. Thank you.